This unit we're going to get into solving rational expressions, rational equations. So rational, if you remember, dealt with like any fractions that can be reduced nicely. So we're going to be, in this lesson today, we're going to be multiplying and dividing rational expressions, as well as determining what it means to be a excluded value. I'm going to start off with the left side here, talk about multiplying. When you multiply, you're going to cross cancel if possible. Divide out the GCF, so always find the GCF of any top with any bottom. Then multiply straight across the top and straight across the bottom to get your final answer. So if we look at this first one here, 12 ninths times 15 fourths. I know that the 12 and the 4 can kind of simplify itself. So 4 can go into 12, you'll be left with a 3. That would cancel this out. If we look at the other side, 9 and 15, both can go by 3, so there'll be 3 here and a 5 here. But you can actually go again and see that this 3 on top and the 3 on the bottom can both reduce to 1s. So I'm actually left with like 1 over 1 times 5 over 1, which goes all the way to just give me 5. If you multiplied it straight across instead, you would have just gotten, let's see, 12 times 15 over 9 times 4, 180 over 36. And if you divide both by 36, you would get 5. But although that may be easier when you only have numbers, we're going to be getting into expressions with different variables. And simplifying first is what's going to make it a lot easier. Take a look at this next one. You always want to see if you can factor first. So you want to factor and reduce. So 4x plus 12, I have a GCF of 4. So I can have 4 and then x plus 3 is left over 3x squared times 5xy over 4y cubed. Let's see what we can simplify. This 4 can simplify with this 4. Remember, any top with any bottom. This x can simplify with one of these x's, so I'm going to be left with 1. This y can simplify with this y, so I'll be left with 2. So multiply across, I have a 5 left. And I have an x plus 3, so I'll get 5x plus 3. On the bottom, I have a 3, an x, and a y. Actually, a y squared, so you get 3xy squared as your final answer. If you can pull out more, you can keep going, but since we don't really know yet, we can't. Let's do another example. 2x plus 2 divided by x plus 3 times x squared minus 9 divided by x plus 1. Factor first. We know that this here is a difference of squares. That's something that should be stuck in our head now. So on the left, you can actually factor to 2 to give you an x plus 1 over x plus 3 times x plus 1 on the bottom, and on top x minus 3, x plus 3. Let's see, you have an x plus 1 and x plus 1 that can both cancel. X plus 3, x plus 3. Therefore, I am left with 2x minus 3. Or if you want to simplify, you can give me 2x minus 6. So that's what you would do when you multiply. So if we read these steps really quick, in the middle it says, if you have more than one term in the numerator or denominator, factor top and bottom first. Remember all the different ways of factoring, including difference of squares, cubes, difference of squares, sum of cubes, grouping for terms, synthetic division, of all the possible zeros. When you finish multiplying, check to see. So when you finish, check to see if it reduces again. We may not have gotten everything. And then lastly, says to write the excluded values. We're going to come back to this step at the end and talk about what that means and how to find them. Let's look at the right side, which is divide. For dividing, it says, take the reciprocal of the fraction following the division symbol. So reciprocal first. Change division into multiplication, then treat it like a multiplication problem. So this would become 12 over 9 times, you would change it to times and flip. And now we can see we can reduce 12 and 15. You can put a 3 in there, so that'd be a 4 and 5. It would be left with 16 over 9 and 5 makes 45. So, same thing with this one here. Keep the first term, so keep, change, flip. Keep, change to multiply, and flip. Now we're going to factor. 7x, this can be 2x minus 5. That's because of GCF. The other side can be, if you use the super x, x minus 5, x minus 6. On the bottom, GCF would be x, x minus 6. What can we reduce? Let's see. I see x minus 6 and x minus 6. X minus 5, x minus 5. X here and x here. Therefore, I'm left with, on the top, only a 7. And on the bottom, I'm left with only a 2. So my answer would be 7 over 2. And the last one. So keep change and flip. That would make that 1 over x squared plus 3x plus 9. This first term here is actually an x cubed minus a 3 cubed. That is a difference of cubes. That equation would give me x minus 3, x squared plus 3x plus 9 all over x plus 2 times 1 over x squared plus 3x plus 9. This cancels with this. Therefore, I am left with x minus 3 over x plus 2. So now let's go back to all these problems. This last step here, which I'm going to highlight again in a different color, says write the excluded values of the variable. The denominator cannot equal 0. So we're going to take the denominators and put it equal to 0 to see what value of x's are excluded. What this means is if you plugged in a value of x that was excluded, you would get an error when you try to solve these problems, because you cannot divide anything. You cannot have a denominator of 0. So let's go and look at this first example right here. Now, excluded values. I'm going to take both of my denominators. So I'm going to look at this one here, set equal to 0, and this one here, set equal to 0. So I get 3x squared cannot equal 0. You divide by 3. X squared cannot equal 0. You take the square root. X cannot equal 0. So if I plugged in 0, I'd get an incorrect answer. I'd get an error. Same with the 4y cubed. Divide. Take the cube root. Therefore, y cannot be 0. So my excluded values are x equals 0 and y equals 0. We can do that for all these problems, and we actually have to do it for all these problems. So if I look at this one here now, excluded values would be my denominators set equal to 0. Therefore, x cannot equal -3 and x cannot equal -1. Let's look at the sentence on the very bottom. Excluded value. Actually, we're going to take a look at this one first. So on this one here, even though it reduces to a whole number, there are still excluded values that need to be determined. When you divide, which means you're going to have to flip it, you must find excluded values from original denominators and flipped denominators, meaning when you flipped it, you have new denominators. So for example, I need to check my original, which is this one, and this one. And then when I flipped, I would also need to check out this one. So original would be this, and these, plus the flipped would be this. I'm going to do each in a different color just so you can see the difference. 2x minus 5 cannot equal 0. X minus 5 cannot equal 0. Therefore, x cannot equal 5. Next one. X minus 5 and x minus 6 cannot equal 0. Split them up. Therefore, x cannot equal 5 and x cannot equal 6. And then the last one, which is when you flipped it. X minus 6 cannot equal 0. Therefore, x cannot equal 0 and x cannot equal 6. So all of my excluded values would be 5. We have a 5 again. 6. We have a 6 again. And 0. 5, 6, and 0. And then we take a look at this last one down here. My excluded values would be this one here. And after I flipped, I need to check this one here. So my excluded values are x plus 2 cannot equal 0, for x cannot equal -2. But now I need to check this one. X squared minus 3x plus 9 cannot equal 0. At this point here, I want to do the quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. And I'm just going to simplify it all. X cannot equal -3 plus or minus the square root of -27 all over 2.